Today I want to talk about parallel circuits and the rules for parallel circuits. And these are integral to understanding how to solve parallel circuits. So the first thing I do when I want to remember the rules of parallel circuits is I draw one. So I'm going to draw a parallel circuit here. There's the source, and I'm going to draw, there's a resistor, and there's the other resistor. Now I know this is a parallel circuit because whatever voltage I have is going to be felt by both legs. There's nothing resisting or preventing both legs from feeling the 12 volts. So that is the definition of a parallel circuit. Voltage is applied to all paths the same. So when we want to figure out the current in these paths, we have to use the Ohm's law triangle, which is E over I R. And the rules tell us that to figure out the amperage in here, so I equals E over R. So E is 12, we have it right there, and R will give it a value of 2 ohms. So if I put this under here, 2 into 12 is 6, so we better put our ohms there. So we got 6 amps there. I'm going to say this one is 3 amps. So 3 ohms. So I'll put my 3 ohms there. So we have 4 amps. When I divide the 4 into the 12. So in order to figure out amps in a parallel circuit, you have to use this Ohm's law triangle and calculate I equals E over R. And we've done that, 6 and 4. Now the third rule pertains to all amperages add up to be the source of the amperage. So IT equals 6 and 4 is 10 amps. Okay, and that's the third rule. Total current flow is the sum of all the individual flows. The next rule, adding resistance in parallel. If I was to add another resistance here, this would decrease total circuit resistance. If I was to subtract it, subtracting resistance increases. So now we're going to see an increase in resistance. Subtracting it, we're going to see a less resistance. So finally, total resistance is less. So now we have to figure out what the total resistance for this parallel circuit is. So let me just get a rag here and give us some space to work. We know that there's 10 amps flowing in this circuit. I'm just going to put it in here so I don't forget. 10 amps. So how we going to figure out our resistance in here is we're going to use a formula called RT, 1 over RT, equals 1 over R1 plus 1 over R2. So simply put, we will take 1 over RT equals 1 over 2 and 1 over 3. Now to solve for this, we have to have a common denominator. So it's pretty clear to me that the common denominator is going to be 6. So to turn this 2 into a 6, I need a 3. 3 times 2 is 6. And 3 times 1 is 3. So 1 over RT equals 3 over 6 plus, turn this to a 6 times 2, 6. That'd be 2. We've got 5 over 6. 1 over RT equals 5 over 6. We will flip that over, and when you flip it over, you get rid of the 1, so we're down to RT equals, since we flipped the RT over, we got to flip that over, 6 over 5. So that's our total resistance in the circuit. We're going to multiply that out in there, and I think we're going to get 1.6. 1.6. So our total resistance, RT, is going to equal 1.6 ohms of resistance. Now the final rule, total resistance is less, so total resistance in that circuit has to be less than the smallest resistor. The smallest resistor is 2. This is 1.6, kind of a check.